So, um, you know, where we are so far is actually it's the first fundamental welfare theorem, right? And what we're trying to lay a foundation for is to be able to demonstrate it. So, how would we demonstrate the first fundamental welfare theorem based on what we know? Well, um, so we've already talked about um, demand and supply and how to interpret them as being the marginal benefit and the marginal cost. Um, but what the first fundamental welfare theorem tells us, right, is that if there is competition, we talked about what we mean by competition. Um, so the competitive equilibrium is efficient. And, you know, there's some caveats to that because, again, we have to understand exactly what competition is. But, um, and I'll just put down the conditions here really quickly. Competition requires no market power. And let me see if I can get this spread out a little bit. No market power. Um, no externalities. And um, I'll just put perfect information. And I will put a little caveat there, like most times what we really mean is symmetric information among the market participants, which means that nobody knows something special about the transaction that the other people in the transaction don't. So that's just a reminder of the basic details for um, the competitive equilibrium to be efficient. And to be clear about it, when we use this term competition properly, we're entailing all of those assumptions. So it means those assumptions are satisfied. Otherwise, there would be no point in using the term competition. We should, you know, qualify it. Say, you know, it's imperfect competition. There's something else going on. Um, so um, how would we demonstrate this? Well, really, what we want to do is we want to take a look at our supply and demand graphs, and what you want to notice, and so here's the demand curve. Here's the supply curve. And here's quantity. And here's price. And so over here, right, all of the units that are to the left of the equilibrium actually have a positive net social benefit. So the way that I'll say that is remember I prefer the term net social benefit. I think it's clearer, but just because you guys might be more familiar with it, there's no problem in using this term total surplus. Over here, total surplus is greater than 0. And um, well, let's see if I can do a good job. And over here, oh, total surplus is less than 0. Now, uh, okay, let me talk to somebody for a minute. Because I just want to make sure that we're all on the same page. Okay. Um, Juan, are you here? Juan Lemus?
Yes.
Hi, Juan. How are you doing?
Good, good. How you doing?
Pretty good. So, do you get what I'm trying to say in this diagram? So, I say total surplus over here on the left, the blue part is greater than 0. But what I really mean is contributions to total surplus. So, if I was going to be, more mathematical, and what I do a lot of times in lecture is let's see, I select this. I'll put a capital Greek letter delta, but I don't have that here, so I can just put a D for the change in total surplus. So what I'm saying over here is that when I add an additional unit and I'm to the left of the equilibrium, it actually has a positive contribution to total surplus. Does that make sense, Juan?
A little bit, yeah.
Well, okay. If it's confusing, tell me or help me, be more clear. What part of it is like what are you talking about, Dr. Hunter? I'm not sure. Like,
I'm not sure. It makes sense, but I'm not sure. Like I want to see it like in a problem. I guess that's what I'm.
yeah, well, and I could give it to you in a problem, and there are problems like this on Ignitium as you work through the supply and demand assignment. But I wanna I wanna be clear about one thing, and that is that you try to understand this diagram kind of in the abstract first, because once you get into the weeds of all the calculations, it can easily, like, you can forget the big picture. And that's kind of a problem, but let me see if I can be a little bit more clear. Um, and since I'm kind of doing like a poll thing, I'll ask somebody else to. So Emily, are you there? Emily? Emily Cobian? Hello? Mm, okay, maybe Emily's not there. I don't know. I don't have the chat up.
Said in the chat her house is under construction right now, so
So who's speaking?
Hannah.
Okay, Hannah, we'll go back to you then since you're here because I don't want to spend too much time. So I'm going to use this little spotlight tool. And what I want you to do is think about if we're at Q is equal to 0, right? Can you see my little red point there? on the graph?
Yes.
Okay. If we're at Q is equal to 0 and we produce our first unit, then remember on the supply curve, and I know I haven't labeled it, but you guys should be able to see the upward sloping curve is the supply curve or the marginal cost curve, and the downward sloping one is the demand curve. Here, right, it's kind of like the problem that we were doing this morning in Ignithium. But remember in that example, Hannah, we were over here to the right, and we got a negative number. Over here, if I produce one unit, I'm going to get a benefit that's going to be measured by the height of the demand curve, and I'm going to get a cost that's measured by the height of the supply curve, and the difference between them is going to be a positive number, and it's actually going to be a positive number of dollars, right?
Mm-hmm.
So it's going to be like, oh, well, this unit brings an additional, I don't know, $200 worth of surplus. And then if I go to unit, 3, 4, 5, all of those are going to bring additional, because the demand curve's higher than the supply curve over here. Those are all going to be positive numbers, right? Because
Equilibrium.
can you speak up just a little bit?
I said as it gets closer to the equilibrium.
Yeah, and those numbers will get smaller and smaller as you get closer to the equilibrium, right? Because remember, total surplus is, I'll put 3 equal sign. It's identically equal to net social benefit. But net social benefit is equal to our total benefit minus our total cost, right? And something else that may be helpful is to say that the change in total surplus is the change is, again, because these are identically equal, is equal to the change in net social benefit. That's what the D stands for, the change in, right? Which is equal to the change in total benefit minus the change in total cost. But remember, there's a special name for the change in total benefit, and that's just marginal benefit minus marginal cost. And I'll put down here change in total benefit. And to be clear, right, change in total benefit, what change, right? It's as we change the quantity is equal to marginal benefit. And the change in total cost as we change the quantity, is equal to marginal cost. Those are definitions. I could use triple equal signs down here. But so Hannah, do you get what I mean here?
You said,
One.
yeah.
Yeah. So remember the demand curve's height, another name for the demand curve is the marginal benefit curve. And another name for the supply curve is the marginal cost curve. So whenever I'm talking about the change in total surplus, I mean the difference between these two curves.
Mm-hmm.
And as long as the demand curve is above the supply curve, those numbers will be positive and total surplus will be growing. That makes sense?
Yes.
Okay. And over here, right, the demand curve's above, the supply curve's above the demand curve. So the marginal cost is greater than the marginal benefit. And the difference between these two curves is going to be a negative number. So, and as you produce more and more, as the cost stays above the benefit, and I also will tell you guys, it's okay. But a lot of times people will call the marginal benefit the buyer's value because it's just, intuitively easy to think about that, right? So as long as the seller's cost is higher than the buyer's value, then those units are actually wasting resources for society. The you know the buyer would be better off if the seller would just stop producing and give them their value, and the seller would be better off too. So so it's a true waste of resources to spend more money making something. And this is, you guys might remember the end of the last lecture, we were talking about my grandmother getting these government cheese blocks, and and I'm sure that cheese costs the cheese producer, I don't know, 20-25 bucks to make, and my grandmother got it for free. But she would have much rather just had the $25 or the $20, and then it's better for the seller because the seller doesn't have to spend 25 bucks producing something that nobody wants. So, but just mathematically, just graphically, you should be able to see that and I'll put a label here as marginal cost, and a label down here as marginal benefit for the demand and supply curves. But you should be able to see that over to the right of the equilibrium, because there's our equilibrium point, these contributions to total surplus are negative, which means it's actually bringing total surplus down. Okay. So does that make sense, Hannah?
Yes.
Thank you. And what about you, Juan? Are you getting a little bit clearer now?
Yes, that definitely helped a little bit more.
Okay. So now you can put specific numbers in here like we do for our problems, but um, um, yeah, it's important to try to connect those numbers up with this big picture, because you can get lost in the algebra of all the calculations. At the end of the day, though, I want to be clear that that demonstrating this point is going to be a demonstration of the first fundamental welfare theorem if we do it the right way. And so what do I mean by the right way? Well, I guess I'm gonna delete that. Um, I'll go back to blue. And what we're actually going to show is, and there's our demand, and here's our supply. What we're actually going to show is that at Q star, which is the equilibrium quantity there, at Q star, total, and I'll just separate with this with an arrow, total surplus, which again is net social benefit, is maximized. And let me talk to somebody else here for a minute. Diego, are you here? Well, you should be here. You got your mic? Diego? I don't know if.
Here in the chat. I don't know if he has a mic.
Oh, okay. So let's try James. James Berrigan, got a mic?
I'm here.
Okay. So how does this demonstrate the first fundamental welfare theorem? Well, what I want you to notice first, and hopefully this is clear, is that Q star is the market equilibrium, right, James?
Mhm.
So that's what the market is picking. So if the market picks Q star and total surplus is maximized, then if we go back, right, we go back to our definition of efficiency. And remember that um, let's see here. Okay. Economic efficiency means that it is not possible to increase total surplus. That's one way of saying it. That's a simple way. So if the market picks a quantity that maximizes total surplus, right, James, it's not possible to increase it any more than that, right? Are
Right.
you with me?
Yep,
Yeah,
yep.
it's at its maximum. Now, I talked about it a little bit last time that it could be the case that there were other quantities that gave the same amount of total surplus, right? But you couldn't get it any bigger. We know that's true, right? I mean, assuming that the first fundamental welfare theorem is is all the conditions are satisfied, and the first fundamental welfare theorem is actually a true statement. But I want to talk about it just a little bit more, because normally the way that we say it is that um, economic efficiency means um, exhausting the gains from trade. That's another equivalent statement. And um, it also means economic efficiency means that there is, well, I'll say no resources are wasted. Okay, so James, we talked about this first statement, right?
Mhm.
Is it clear that these other two statements are equivalent to the first one?
I believe so. Yeah.
Okay, well, let's talk about the second one. Okay, economic efficiency means that no, that means that all the gains from trade have been exhausted. Can you walk us through that a little bit? Like, what are we talking about?
So if you reach market equilibrium and you have a total surplus in a competitive, like in a already efficient market, if you're already producing more than you already need to because you already maximized them, it's just, at that point you're just kind of wasting resources because there's not a demand for it.
Well, remember the second statement was this: economic efficiency means exhausting the gains from trade. So, what are the gains from trade in this diagram?
The left side, the green.
Oh, it comes up green on yours. This is blue to
Yeah.
me, but
Yeah.
light blue. Maybe it's turquoise. Um, so okay, you say these are gains from trade over here on this left side,
Mhm.
right? But how is it a gain from trade? Can you explain that to me?
Um, can you, no.
No. Okay. So let's talk a little bit about trading. what does trading involve?
Two or more parties exchanging goods or services.
Well, yeah, and in our case, and this is something you kind of bring up. You said two or more parties, but a trade is always between two parties, right?
Mm-hmm.
And I think this is probably, you know, maybe you want to think about it in a simple way. One of the parties is what we would call I'll let you fill in the blank.
A producer,
And the other party is,
a consumer.
yeah, so a buyer and a seller, right?
Yeah.
Those are the types of trades or transactions that we're talking about. Now, in this diagram, can we see that a buyer and a seller have a potential gain from trading?
Yes.
Okay, so you want to tell us, let's go ahead and we'll do a specific example, right? So suppose this is the Q, and I'll use little q just for a particular unit. Q is equal to 10. And okay. So, and I'll try to label it on the diagram for us. So suppose that point right there is Q is equal to 10, right?
Mm-hmm.
So for this 10th unit, what's the gain from trade? How would I identify that?
What people are willing to pay for that Q of 10.
Yeah, okay, so I would go up here and I would look up at the demand curve and I'd say, oh, there's some buyer there and I can get his willingness to pay, boom, from that diagram. And just to be a little bit concrete about it, in case anybody's wondering, right? I mean, if I plug Q into this function, I would get some value out of it, like maybe 25, and remember, it's going to be dollars, right? So $25, right?
Mhm.
And so that's going to be what we would say the buyer's willingness to pay, what they're willing to pay for that 10th unit. And I suppose I could make this a little bit right. So that's that point there, right? So, and then the other party is our seller, and then how do they factor in here?
So, like, how do you mean?
Well, okay, so we have the buyer's value,
Mhm.
right? The buyer's willing to pay $25, and then so what's the gain from trading that we're talking about?
So, like, if the seller buys the product at $10 or something like that, then they would gain $15.
Well, okay, you said this the seller buys the product. So yeah, you're kind of talking about retail versus wholesale, right? Like
Mm-hmm.
Target. But let's just talk about producers because it's clearer there. Because the resellers are like, retail services that they provide maybe confuse things a little bit. But let's suppose, somebody produces, something, right? What do they pay for it? They have their
Their marginal cost.
yeah, they have a cost of production,
Yeah.
right? And so we can identify that cost of production as being the height at Q equals 10 of the marginal cost function. That's the cost of that unit. So yeah, so let's say that this is like um, $15, right? So we'll kind of move it over a little bit and we'll draw another little arrow. Okay. So yeah, we've got a seller that has a cost of producing that 10th unit, which is $15, and a buyer that has a value for that 10th unit, which is 25, right? And so then what are the gains from trade?
Like $10.
Yeah, so it's the difference between the willingness to pay of the buyer and the cost of the seller. Now, did we mention a price? What's the buyer going to actually pay?
25.
Why? Do you pay the maximum willingness to pay for every single good you ever purchase? You personally?
No, because sometimes you'll look for a better deal.
Well, yeah. So these are actually the difference there. The $10 are gains from trade, but they're potential gains from trade, in the sense that it depends upon whether or not they actually trade this unit. But if they do trade it, those will be realized gains of trade, but we don't know how the gains from trade will be distributed between the two parties. So, for example, one of the things I didn't mark here is I didn't mark an equilibrium price, right? And you can see the equilibrium prices between the two. If we had it here, right, it'd be something like $20, right?
Mm-hmm.
And if the buyer paid $20, then they would have $5 of those potential gains from trade, right? Because they'd be paying 20 for something that's worth 25 to them.
Mm-hmm.
And the seller would have a cost of 15, and they'd be selling it for 20, so they'd have like $20 of $5 of that gains of trade going to them. I didn't give labels on those things, right? The truth is that we do have labels for the division of the gains of trade between the two parties. If I say this is P star is equal to 20, there, right? Then there's consumer surplus, which is equal to willingness to pay minus P star. That's the buyer's portion of the gains from trade that the buyer gets to keep. And we also have producer surplus, which is equal to P star minus, I was going to say marginal cost, but I'll just say cost. Okay. To keep it simple. And so these are potential for gains from trade, whether the price is $20 or if the price is 22, or even if the price is 25 and the buyer pays their maximum willingness to pay, right? It's going to affect the division of the gains from trade. It's going to affect how much consumer surplus the consumer gets and how much producer surplus. And by the way, I'll tell you, James, it's helpful to think about producer surplus as being contributions to profit, because that's normally the way that we would think about it. That if I get more producer surplus, I'm getting a higher price as a producer than my cost of production, and so my profits are going up. So yeah, if the buyer pays their maximum willingness to pay, then all of the gains of trade go to the producer. But if the price is lower, like 15, and there's sellers selling for their cost, then all of the gains from trade go to the buyer in terms of consumer surplus. Does that make sense?
Yeah.
Yeah.
Makes
And,
perfect sense.
and when we say that we're exhausting the gains from trade, what we mean is at Q star, at this point, the gains from trade are what?
Yeah. $5.
Well, no, now think, right? So that's at Q is equal to 10.
Oh,
Right.
at equilibrium.
Yeah, at equilibrium.
Mhm.
When we go past 10, we go to like to 11, to 12 units, to 13 units. I don't know what the equilibrium quantity is in this example. But if we get to the equilibrium quantity, what are the gains from trade there?
Mm,
Does anybody want a volunteer? You can put vol in the chat and we'll talk to you if you want to volunteer. We're asking, what are the gains from trade at equilibrium? No volunteers. Okay. Well, we said that the gains for trade for this 10th unit were this whole distance between 25 and 15, right, James?
yeah.
Right. So at the next level, right, of production, like Q equals 11, the gains from trade would be bigger or smaller than smaller, right? So if they're $10 here, it's smaller here, right? And then still smaller and still smaller as we increase production to eventually the gains from trade for that last unit are what?
20.
Well, let's think about it, right? So the gains of trade are between the consumer and the producer, right?
Yeah.
And here, what's the buyer's value? What's their willingness to pay for the one that buys the Q star unit? What's their willingness to pay?
5 minus, so 5. Or
Well, are you looking at the height of
yeah, I
of
just
the?
did 25 minus 20.
No, see, well, you're getting stuck on Q is equal to 10.
All right. So it'd be a different price. So I'm not sure.
Yeah, okay. Okay, well, think carefully about what you're doing. So let's see. Z wanted to volunteer. Are you there, Z?
Yes.
Can you speak up a little bit? You're a little bit quiet.
Can you hear me?
Yeah, I can. Okay. Okay. So take us home. What happens here?
Uh, equilibrium. The equilibrium point. I think the gains from trade at this point will be.
I'm waiting for you. I don't hear you. Gains from trade will be what?
$20.
No, it's 0.
Yeah.
Right? Because see what's going on is at Q equals 10, the buyer has a value of 25, which is the height of the demand curve. Here, the height of the demand curve is 20 because we said that was here, I'll draw an arrow here, right? This is the equilibrium price. So the height there is 20. Okay. So I'll switch to my spotlight, right? Oh, it's like I'm still getting this silly arrow here. So here, the height of the demand curve, which is this marginal benefit curve, is 20.
Yes.
The price is 20. So the willingness to pay is 20 and the price is 20. Consumer surplus is 0. Producer surplus, right? The height of the marginal cost curve is 20. So the cost is 20. The price is 20. Producer surplus is 0,
I see.
right? So what we're talking about is the change in total surplus, right? The change in total surplus as we increase our quantity of production, the change in total surplus gets smaller and smaller. The change in total surplus is the gains from trade. It is the potential gains from trading between the two parties. And when we have this statement here that economic efficiency means exhausting the gains from trade, what it means is making those gains from trade go to 0, letting the change in total surplus go to 0. So for those of you in the class that have had calculus, right? And those of you that haven't, you don't really need calculus to understand this, but there's all this conceptual stuff, is that we're talking about in mathematical terms, economic efficiency means that the derivative of the net social benefit goes to 0 as Q, which is the quantity of output, goes to Q star. Okay. So I don't know if it's really clear or not clear, but there are a couple of takeaway points here. One is contributions to total surplus are positive to the left of the equilibrium. So there are gains from trade. Buyers have a higher value than the seller's cost for all of these units from Q equals 0 to Q star, whatever. And I didn't put Q star on this diagram just because the diagrams get cluttered quickly, but I'll put it here just
I have a quick.
Okay, let me finish with my summary really fast. Okay, because I'm almost done. So from 0 to Q star, we've got this shrinking change in total surplus, which means the gains of trade are getting smaller and smaller until they hit 0. Over here, right, we've got negative changes in total surplus, which means total surplus would be going down. That's not really important, but for the first fundamental welfare theorem, in the sense that it doesn't help us, better interpret exhausting the gains from trade, but we got them to their maximum, and the final gains from trade are 0. The one other thing we didn't finish talking about, and I think we got to wrap it up. So I'll just say this really quickly and then I'll answer your question, which is economic efficiency means no resources are wasted. What we mean really about that is, thinking about it from a maximum Q going down to Q star, everything over here represents a waste of resources, because remember, resources are anything with an opportunity cost, but we normally break them into land, labor, and capital. There's land, labor, and capital that's being used to produce output over here, but the cost of it's higher than the value to the person that would end up consuming the good. So that's a waste of resources, because you could just give that person that equivalent amount of money, I mean the buyer, and save all of these additional costs that are represented by the difference between the marginal cost and the marginal benefit. Or you could erase all of those negative changes in total surplus by just doing a direct transfer of money and sticking along this marginal benefit line, right? Anyway, it's worth thinking about it. I would recommend taking a screenshot of this diagram and thinking about it. In fact, you know what I'm going to do? I'm going to take a picture myself because I thought the repeated Zoom meeting would save our whiteboards, but it didn't. So, okay. Anybody else have a question? So it was Z, you were going to ask a question?
Yes.
Go ahead.
I was just wondering, why does marginal cost grow as production goes up?
Well,
Shouldn't it goes down as production goes up for each individual?
Okay. So we actually have to talk more about that later on in the course. We're going to talk about cost functions more. But when I first introduced this, I said there's this general idea of diminishing marginal productivity. But probably what you're not thinking about, what most people don't, is they don't think about the cost of production as you hold the capital fixed. Remember, capital is machines, tools, and equipment. That's like the size of your factory. So imagine a fixed factory size. You've got so many square feet of factory. You know, maybe it's 2,000 meters, right? Squared meters of factory space. And now think about increasing your production. Well, eventually, right, you're going to have to pay your workers overtime. You're going to have to run 3 shifts, and that'll make your cost per unit go up. Does that make sense?
Mm.
Yeah.
Yes, it's just that, you know, in fundamental of macroeconomic, they always said that as production goes up, marginal costs will go down because the scale.
Well, see, and actually, I have to say that I don't know who in macro told you that, but so there is, and we'll talk about this, right? If you don't hold the scale fixed, if you increase the scale, there are a few cases where you get decreasing marginal costs throughout. But what I would encourage you to do is to really think of those as being rare examples. In most cases, even in the long run, when you increase scale, you eventually get increasing marginal costs. And we'll talk more about that later. But the problem is you just have to do a thought experiment, right? Whatever you think is the biggest scale, make it bigger, and then make it bigger, and then make it bigger. And what you're going to realize is that eventually you end up drawing in resources that are inefficient for the purpose of producing that particular good. Think about things like, I don't know, pick a good, any good, cell phones or healthcare, right? And think about ramping up the scale and making it super huge, right? Well, eventually you're going to run out of people who are well-qualified engineers to design cell phones, or you're going to run out of people that are well-qualified doctors to treat people. And then you're going to be taking resources that are not well-suited for medicine, just in labor alone, but you could think about other resources too, right? And that's going to make the cost of increasing the output to get higher and higher, right? Imagine you want to have so many physicians that half of your population is physicians. Do you really think that half of the population is suited for medical training, or that they could be trained in a reasonably quick time? I would say no, right? I mean, I say well suited because some people just aren't interested in being a doctor. I've got 4 children, and one of my children wants to be a doctor, and the other 3 think that blood is gross and can't imagine the idea. So, can you imagine trying to train people like that to be doctors? People that really don't want to do it?
Oh, I see. Perfect.
I mean, are they gonna be trained easily? Are you gonna be able to pay them? I mean, I know like one of my daughters, if you asked her to be a doctor, even if you said it was free for her to go and everything like that, she would want you to pay her like 5 times the average doctor salary because she hates the idea of doing it. So, yeah, I mean, a lot of times people think that you can just increase scale and you'll naturally decrease cost, but it's because they're not really thinking very carefully about it. If you really did, then you would say, that's not a good argument.
All right.
Uh, if you make the scale really big. I mean, even if you think about something like, you know, um, you know, increasing the scale of road production, right? Well, there's some places where it's really hard to build roads, and normally what happens is that the first roads that get built, they get built on the easy, low cost way of building. And then if you build even more roads, you're going into territory that's really tough and it just gets more expensive. So anyway, I digress. But yeah, marginal costs, the general rule is that marginal costs do increase even in macroeconomic contexts unless there's something special going on. And anyway,
So economy of scale generally only applies for a short period of time before.
yes, yeah. Economies of scale have limits to them, and you have to really think in the particular case that you're talking about, um, if if um, if they do apply and to what extent they apply. So, but we'll talk more about that
Thank you.
later. Sure. Okay. So it's 9:40, and I think that I've given you guys enough to think about today. Go ahead and continue to work on the Ignithium homework on supply and demand, and we'll continue on next time. Okay. If you guys have any questions, let me know. Okay.
When is the Ignithium homework due?
Well, it was due, right?
Well, not the assessment, the new one, the supply and demand one.
Oh, I would say probably next Tuesday would be a good target. We should have gotten through that homework by then. And um, yeah, so I would say next Tuesday is probably a good target.
Okay, sounds good.
Okay, all right. Bye.